that pressure, okay? We're going to continue this when we talk about gas laws, but I've got to be able to define a certain number of words, okay? Clear? Keep this brief. This is a little bit more conceptual than what we've been doing the last week or two. Here are some physics formulas, okay? I'm not teaching you any more than this, okay? F means force. W is weight. So I am about 100 kilograms, correct? That's my mass. If you multiply by acceleration, mass times acceleration, we're going to round it to 10, okay? It's really 9.81, but we're going to say 10. If I say to you, my mass is 100 kilograms, my weight in the metric system is going to be 10 times that. So it will be 1,000, right? Because it's times 10. If I take 0.1 kilograms, if I only take 0.1 and I multiply it by 10, that equals 1. That's the definition of what we're going to talk about today. It's the definition of the term Newton after Sir Isaac Newton. N, capital N, is the abbreviation for Newton. Sir Isaac Newton. Okay? So, my weight, Darcy's weight, is 1,000 newtons. Okay? So far, so good? Yes? Whatever your mass is times 10 is your weight in newtons. Clear? Now, I want to look at a box. That box is going to be 1 meter by 1 meter by 1 meter. Clear? It's going to be 1 cubic meter. You okay with that? It's like right here. It's like right here. It's like this wide, this deep, right? Get it? 1 meter, right? If I fill that completely with water, what's wrong?
It says low battery.
It says low battery. We'll ignore that. Okay. If we fill that with water, right? I'm going to be able to fit in there 1,000 liters of water. Correct? 1 liter equals 1,000 milliliters equals 1,000 grams equals 1 kilogram. Right? So it's going to be 1,000 kilograms, correct? So if I have a box full of water, I can fit 1,000 liter bottles in there, and it's going to be 1,000 kilograms. Do you get it? Okay, so I'm going to have a 1 cubic meter box filled with water. Now, can you imagine if you were under that? That would be really heavy, correct? That'd be really, really, really heavy, correct? Now, the box sits on the ground, and it's going to be 1 square meter. That's going to be the area on the ground. And you know from basic middle school science that pressure equals your weight over your area. Correct? Yes? Basic middle school math equation. All right, now. So, this is going to be 1,000 kilograms. What's going to be the weight of 1,000 kilograms? What's going to be the weight? 10,000 newtons, right? 1,000 kilograms times 10 would be 10,000 newtons, correct? 10,000 newtons per 1 square meter, correct? Yes or no? You get it?
No.
No? Who said no?
Me said.
Okay. I have a box. The box is filled with 1,000 kilograms of water, correct? Mass times acceleration. 1,000 times 10 is 10,000. That's the weight in newtons. So it's 10,000 newtons, correct? I'm almost finished. 3 or 4 more minutes, okay? Now, I've got to give you a term. 1 Newton per 1 square meter. If I had just 1 Newton per 1 square meter, that would be called a Pascal. That's the pressure, Pascal. Named after Blaise Pascal. We won't talk about him today. Okay, so 1,000 kilograms times 10,000 newtons per square meter, that's 10,000 pascals, correct? Yes?
Yes.
Okay, now, let's say I have a stack of those cubic meters, and you're under it. I put 10 of them on top of the floor. 10. It's 10 meters tall, right? 10 meters tall. Yes?
Yes.
Okay, it's going to be 10 times 10,000. I'm going to erase some of this. Is that okay? I'm going to erase this. Okay? So it'll be, if I have a stack of 10 boxes, Nazim, each one weighs 10,000 newtons. How many newtons is 10 boxes going to be?
100,000 newtons.
Yes! So it's 100,000 newtons, right? Over 1 meter squared, right? How many pascals is that? How many pascals is that?
100,000.
That's right. 100,000 pascals. Right? Yes? You're with me? Okay, good. Now, so can I say, instead of running around screaming 100,000 pascals, I'm going to say 100 kilopascals. Is that right? Is that okay?
Yes.
Yes or no?
Yes.
Okay, you're sure?
Yes.
Okay, good. That is the weight of 1 atmosphere per square meter, 100 kilopascals, plus a little bit more. It's actually 103.5 kilopascals. Okay, but that's approximately it. Okay, this is 1 atmosphere. The total gas, if I take 1 cubic meter, right, on the ground, and I magically make this tube 30, 40, 50 kilometers straight up, the pressure that tube, the pressure of the gas in that tube that it exerts on the ground is approximately 100,000 pascals, 100,000 newtons per that square meter. We will be using a lot. We will be using pascals, kilopascals for the rest of the year. Understood? Pressure in chemistry is in kilopascals or pascals, depending. Air pressure is 100 kilopascals. That's it. Clear? You okay with that? Any questions? Yes?
But for that example, did you just take a random acceleration? Did you just take a random acceleration?
No, that's the acceleration due to gravity. That's a very good point. The acceleration due to gravity. This pen is going to accelerate at 10 meters per second every second. So after 1 second, how fast is it going? 10 meters per second. After 2 seconds, how fast is it going? 20 meters per second. Every second, it's going to increase its velocity 10 meters per second. It's not random. But I want you to understand that the physics is very simple. I'm just using the physics to help define the term. When you say around, when people ask, well, how much do you weigh? How much do I weigh? Whatever you say, 50 kilograms. That's actually a mass. In metric, you would be X number of newtons. My weight is approximately 1,000 newtons. I know, too much. Understood? Any other questions? No? That it? Okay. We're off. Have a great vacation. Study only if you wish. Test is Thursday upon our return on moles. It will be all the mole calculations, empirical formula, and that's it.
Okay, I'm in the church.